So in this example, ladies and gentlemen, again, the first thing that we need to do is we need to identify the LCD. LCD, again, is just going to be the product of the denominators. It's really redundant. All right? But you guys got to know the difference of when you're solving and when you're adding. When we're adding, we're trying to get common denominators. When we're solving, we're trying to get rid of the denominators. So what I'm going to do is I'm going to take my LCD and I'm going to multiply it by every single term. So I multiply 3x times 2x plus 5. Multiply it by this term. I have to multiply it by my middle term. And I have to multiply it over here. Does everybody see that? Okay. So now, over here, we can see that 3x plus, or 2x plus 5 divides the top and the bottom. So I'm left with a 3x times 7x plus 1. Over here, multiplying by 1 is just going to leave you with plus 3x times 2x plus 5. And then on the right side, my 3x's divide to 1. And I'm left with a 10x minus 3 times 2x plus 5. Now this is going to be fun. So what we have to do here on the left side is we have to apply distributive property. On the right side, we need to apply FOIL, which is really just a fancy way of doing distributive property. So over here, I have 21x squared plus 3x 1 times, I had to multiply it by my LCD.
So it doesn't really mean anything?
Well, what's 1 times 5? 5. What's 1 times 3x times 2x plus 5? 3x times 2x plus 5. See what I'm saying? So then I apply distributive property here. So that becomes a 6x squared plus 15x equals, this becomes 20x squared plus 20x minus 6x minus 15. Now, for diamond, we will group and combine on each side first.
Wait, can I just write that down?
Sure. Got a marker in my pocket. You're right. No, very, very much so. So we have 21x squared plus 6x squared gives me 27x squared. 3x plus 15x is going to be 18x equals, let's see here, I got 20x squared. 20x minus 6x is going to be 14x minus 15. Now, we basically want to solve for 0. So we get all the x's to one side here. So I'm going to subtract the 20x squared. I'm going to subtract the 14x. And I'm going to add the 15. Yes? I'm just undoing everything on the right side. 21 plus 6. So now I have 7x squared plus 4x plus 15 equals 0. So now what we simply need to do is we need to solve for 7. We need to now factor this, right? If we're solved, this is a quadratic, so we've got to be able to factor it. Now, ladies and gentlemen, you could obviously use the diamond method, but I really don't want to multiply 7 times 5, that's going to be 100. What two numbers multiply 105? I had to give you 4. We could probably figure it out if we thought about it. But the other way to do this is think about your factors. To multiply to give you 7x, it's going to have to be 7 or x times 5. Then I basically just think about my factors of 15, which are only 15 and 1 and 5 and 3, right? So it's really going to be like 5 and 3, which we can interchange, or 15 and 1, which we can interchange. Or 15 and, 1. So I look at this and I just try to see which ones would kind of make sense here. They're both positive and they have to add. That's not going to work. That's not factorable. That's not going to be factorable. No, you got to solve. So it's either I wrote down the problem again wrong. 2x plus 5 divided by 2x plus 5 plus 1 over 10x minus 3 divided by 3x. Oh, 34 has no solution. No, we're doing 30 is 5/7. OK. So let's look at this one. 5/7.
We could just stop here and have it. Let's just go to this one.
All right. This shows the easier way to do it.
Kujan, you said that one time and nobody laughed.
No, I'm dead serious.
I know, but you said that the first time and nobody laughed.
Nobody was supposed to laugh. I don't want to do it to farm.
Well, good. Well, then that's what you'll be left with then. This is the method of what you've been doing. This is how we've been. All we did, Kujan, it's the same method. I started off with a very, very basic problem, which was like the numbers. Then we moved to one with one variable. Then we moved to one with another expression. Now we're working with one with multiple expressions. So it's the same process, but we're getting into more and more complicated problems. So if I multiply, I'm doing everything 3x. 3x plus 2x plus 5, that becomes 6x squared plus 15x. 20x squared. Has anybody seen any? I did make a mistake. OK. So that's 10x squared. Yeah, it's 50x. Where did I? 10x times 5 becomes 50x. 50x and minus negative 6x. All right, so then that becomes a negative 46, or a positive 46x. I didn't do 10x times 5. I didn't do 10x times 5. So 10x times 5 is going to become 50x. OK? And it's still minus 6x. So then that becomes a positive 46x. So I'm really subtracting 44. Thank you. So I'm really subtracting a negative 44x. So when I subtract a negative 44x, my factor is to become different. So now my middle term is going to become a negative 44 plus 16. So that becomes a negative 26x. All right. So now let's go and see if that is factorable. So if I were going to replace these, so now we know that both my terms have to be negative. So let's see, does this work? Does negative 5 and negative 3, does that work? We know that negative 5 times negative 3 is positive 15. 7x times x gives you 7x. But does my middle terms, does negative 5 times 3 and does 7 times negative 3, does that give me negative 26? Negative 5 times x is what? Negative 5x. 7x times negative 3 is a negative 21. So guess what? It works. Yay. So you guys can say that that becomes 7x minus 5 times x minus 3 equals 0. Now you can apply your, now what we can do is use our zero product property and say 7x minus 5 equals 0 and x minus 3 equals 0. So therefore, x equals 5/7 and x equals positive 3. And both of those are solutions, can be solutions to our problem.